Hello everyone, welcome to Witness Coder. So today we are going to look at right view of a binary tree. This problem has a two approach to solve. First one is recursion and second one is level order traversal. So if you haven't watched our previous video of left view of a binary tree, then I would recommend you to go to the channel and please check it out. So it has been done via recursion. So now we are thinking a different approach to solve this problem. So as the problem suggests, we need a right view of a binary tree, meaning if we view this tree, this given tree from the right hand side, then which nodes that we are able to see, those they need in output. Here 1, 3, 7 and 8. If we see this tree from right hand side, then these are the only nodes that are visible. Rest of them are get overlapped by these one, and same goes with the other examples. uh, for convenience, I have taken an example of that in separate notepad, you can say. As we can see, node 10, node 30 and node 60 are the one those we can be viewed from the right hand side. As you can see here, every time when you see from right hand side, these are the only nodes can be visible. Rest of all, like this 20 and this 40, these are overlapped by 30 and 60 respectively. So as the approach suggests, we are going level by level, meaning like as I'm showing it to you. As we can see here, every time when we are thinking of a level, this 10 is present at level 0, 20 and 30 level 1 and 40 and 60 at level 2. So if we go via level 0, level 1 and then level 2, then we have to maintain a mapping between these, because every time when we are checking for each node, so each node present at certain level, you can say, and each node is having a certain value to it, attached to it, you can say. So level and a value, so we need mapping of level and value every time. So right, we are thinking of a data structure map. So it will be having a level and a value respectively in its data structure, you can say. So every time we at first, if we are thinking of having or being at level 0, then we are having 10. So then for 0th level, you can say we are having 10 with us. Then for first level, at first we'll be having 20 with us. So next time when we come again for the first level, because it is having a left and right child, so it's likely to happen. So for first again we would be having 30 for next time approach. So what is happening here, we are entering a value for the same level. So in map, if we try to put a value for the same key, then the previous value get replaced. So here in this case it will be 130. Same goes with the level 2. So at first it will be like 2 comma 40, and next time when we insert it again, it will be like 2 comma 60. So what we have to do in the end, we just have to pick these values, sorry, uh, these values, then 30 and 60. So these values, and every time when we do a sorting of them, then we would be getting our output which is present here. So let's start coding and we'll see how it goes. Okay, so first of all we need an array list to return an answer. So okay, we are creating one of integer type, saying list as an array list here, and we are checking at start only our base condition, or you can say boundary condition. So if it is null on the right away, we are returning our empty list, because we don't have anything to go further. We're taking one queue having of type this node, having implementation as a array dq. Later we're thinking of a mapping. As we have said, we need a mapping of level and a value. So we are checking map, which will be of level will be of integer and value also will be of integer, saying these are mappings, storing them in hash map. Now for the first value, we are thinking of adding into queue, this node. Along with that, we are also adding -1 to the queue, which is a new node. Why we are doing this? Because every time when we are traversing these levels, we need to know at which point a level has end. So that's why we have taken this approach. We need one parameter as a level to track levels. Now, following with our approach, we are checking whether our queue is empty or not. It is obviously not, because we have already added a root node to it, the first one. Then we are retrieving it from this queue, because we need to go ahead with this. We are checking if this node that we have retrieved so far, it is having this value or data as -1, because we need to track our levels as well, right? So that's why we are checking it upfront. Then we'll be incrementing the level, because we have already crossed one level. Again, once we have retrieved that -1 from the queue, we need to check whether this queue is empty or not, whether it has further values or not. So we are checking it again whether it is empty or not. If it is not, then again we are adding into this queue the same value, -1, because it is having further values into it, and we need to keep a track of these levels. And in else part, if it is not -1, then it is having a certain value. Here we are inserting it into mapping. For this level, add this data. So data has been added, and now we are checking if this front node of ours is having left or right child or not. If it is having a left child, we're adding it into queue, and same goes for the right one. Okay, now right. Okay, we have taken care of that as well. Now everything is done, I guess. And once it is in mappings, we just need to make sure to sort them. So for sorting purpose, we are taking tree map here, making sure it is of same type as our mappings are. We are considering it as a sorted one, because it gives by default ascending or natural sorting order. And we are creating a equivalent tree map for our mappings. Once it is done, we are checking, or we are interested in value part. So we are iterating this map, saying map.entry every time of same integer, a one entry for this entry set. From this entry is a retrieval process of a map, or traversal process of a map. So from this entry you can avail key and values as well. So for now we are interested in value only. Here we are doing list.add entry.get value. So okay, and these values has been added. Now what we will be doing, we are returning this list. Okay, I think we are done with the code. Let's try submitting it and see how it goes. Maybe we are missing something here, cannot find a symbol. Okay, q, only q we have written, line number 143, up. Okay, here also we need to do q.offer. Next, now we have done q.offer. Again, mappings dot, okay, for mappings we have not written anything here. Mappings.put, it is a map, has to be this way, a map put method into map. Now okay, our output is correct for this input. Let's try for another input as well. Okay, we'll try for this 10 20 30 40 60 nn. Okay, 10 20 30 40 60 and n. Okay, let's see if it matches to our expectations or not. Let's try. Okay, it is also right one. Let's try submitting it. Okay, test cases, pass. Okay, it's done. So all test cases has been passed. The time complexity of this solution is big O of n because we are traversing all the nodes at once. And for space complexity, as we can see, we have taken this array list was given in the or asked in the question itself, so cannot be considered. Apart from that, queue we have taken and map we have taken, and in this we are adding the nodes up to value n, all the nodes up to like height of the tree, you can say. Then you can say order of n for space complexity as well. So yeah, that's it for this video. Thanks for watching.